Now I am going to take up some higher level problems. But before taking up these problems, I would like to discuss some basics that will be required for understanding these problems. So first of all, I discuss the basics. Now while studying trigonometrical equations, we have studied that sine beta is equal to sine alpha. Then the general solution is beta is equal to n pi plus minus 1 to the power of n into alpha, where n is an integer. Sine beta equal to sine alpha implies beta is equal to n pi plus minus 1 to the power of n into alpha. That is, sine alpha is equal to, beta is this much, so sine alpha must be equal to sine n pi plus minus 1 to the power of n into alpha. If alpha is one of the solutions, then the general solution is n pi plus minus 1 to the power of n into alpha. If sine beta is equal to sine alpha, then this relation must be true, that sine alpha must be equal to sine n pi plus minus 1 to the power of n into alpha. Similarly, cos beta equal to cos alpha, then beta must be equal to 2n pi plus minus alpha. That is, cos alpha must be equal to, now put the value of beta here, cos of 2n pi plus minus alpha. That is, if alpha is one of the solutions, then general solution is 2n pi plus minus alpha. And similarly, tangent beta is equal to tangent alpha, then beta must be equal to n pi plus alpha. That is, tangent alpha must be equal to tangent of n pi plus alpha. Tangent of n pi plus alpha is one of the solutions, then the general solution is n pi plus alpha. And we have also studied in inverse trigonometrical functions that domain of sine inverse x is minus 1 to 1 closed interval, and its range is minus pi by 2 to pi by 2. Range of cos inverse x is 0 to pi. Domain is minus 1 to 1. Range of tan inverse x is minus pi by 2 to pi by 2 open interval. Both these points are excluded. And domain of tangent inverse x is whole real line. With this background, I will find the values of some inverse trigonometrical functions. First is, suppose we have sine inverse of sine pi by 4. Then this must be equal to sine inverse of sine is f inverse of f is identity. So this will be identity of pi by 4, I pi by 4, and I pi by 4 is pi by 4. So this must be equal to pi by 4, and pi by 4 belongs to the range of f. Range of f is minus pi by 2 to pi by 2, and this belongs to the range of this function. So sine inverse sine pi by 4 is pi by 4. Cos inverse of cos pi by 4 is equal to pi by 4. Cos inverse cos is identity, and I of pi by 4 is pi by 4. This also belongs to range of f. And tan inverse of tangent pi by 4, this is equal to pi by 4, and this also belongs to the range of f. A function can take values only inside its range. So this is the value of this function. So this value must be inside the range of this function. Pi by 4 belongs to this, this is the correct value. This belongs to this belongs to this. And sine inverse of sine, say 3 pi by 4. Sine inverse of sine 3 pi by 4 is equal to, if I write this is equal to 3 pi by 4, but 3 pi by 4 does not belong to the range of f. Though this cannot be the value of the function. This cannot be equal to 3 pi by 4 because does not belong to range of f. Because it does not belong to range of f. The range of f is minus pi by 2 to pi by 2, but this does not belong to this. And no function can assume values outside its range. This lies outside the range, therefore this cannot be the value of the function. Therefore sine inverse sine 3 pi by 4 is not equal to 3 pi by 4. Cos inverse of cos 3 pi by 4. Now this is equal to 3 pi by 4 because this belongs to the range of f. Range of f is 0 to pi and 3 pi by 4 is 135 degrees. So it belongs to 0 to 180 degrees. So this belongs to the range of f. So cos inverse cos of 3 pi by 4 is 3 pi by 4. Sine inverse of sine 3 pi by 4 is not equal to 3 pi by 4 because it does not belong to the range. This belongs to the range, therefore this can be the value of cos inverse cos 3 pi by 4. And similarly for tan inverse of tan 3 pi by 4. This is not equal to 3 pi by 4 because this does not belong to the range of f. This does not belong to the range of f. Therefore, it cannot be a value of tan inverse. Now, in these two cases, what should we do? Because this is not the value of this. So, what we do is we make use of this result. We know that sine of 3 pi by 4 is equal to sine of alpha is sine of n pi plus minus 1 to the power of n into alpha. So this must be equal to n pi plus minus 1 to the power of n into alpha. Alpha is 3 pi by 4. This is 3 pi by 4. Now what we do is, now sine of 3 pi by 4 is equal to this much. These two values are equal. Now what we do is we choose n such that this value belongs to the range of f. This is within the range of f. We choose n such that this is within the range of f. So say n is equal to say 1, and if I take n equal to 1, this will be pi n equal to 1 minus 3 pi by 4. Pi minus 3 pi by 4 is pi by 4. So this is within the range of f. So for n equal to 1, this belongs to the range of f. But if I take say n equal to 2, then this will be n equal to 2 pi, n equal to 2 is plus 2 pi plus 3 pi by 4. So this is will be equal to 11 pi by 4, which is not inside the range of f. For n equal to 2, this does not belong to the range of f. For n equal to 1, this belongs to the range of f. So we choose n such that this belongs to the range of f. So I take n equal to 1. So this will be pi minus 3 pi by 4. And we know sine of 3 pi by 4 is equal to this, and this is equal to this. So sine of 3 pi by 4 can be written as sine of pi minus 3 pi by 4. This is equal to sine of pi by 4. Therefore, 2 implies sine inverse of sine 3 pi by 4 is equal to sine inverse of sine 3 pi by 4 is sine pi by 4. So this is sine pi by 4, and this is equal to pi by 4 and this belongs to the range of f. So value of sine inverse sine 3 pi by 4 is not 3 pi by 4 because it does not belong to the range. But value of sine inverse sine 3 pi by 4 is pi by 4 and it belongs to the range of f. Value of cos inverse cos 3 pi by 4 is 3 pi by 4 because it belongs to the range of f. And for this again, this does not belong to the range of f. So what we do is we write tan of 3 pi by 4 is equal to tan of, now tangent of beta is equal to tangent of alpha implies beta is this much. That is tangent alpha is tan n pi plus alpha. So this is equal to n pi plus 3 pi by 4. N pi plus 3 by 4. 3 pi by 4. N pi plus 3 pi by 4. Now we choose n such that this belongs to the range of f. Suppose I take n equal to 1. Then this will be pi plus 3 pi by 4. But pi plus 3 pi by 4 is not within the range of the function. So n equal to 1 is not the correct value. Take some other value. Take n equal to minus 1. So minus pi plus 3 pi by 4 will be minus pi by 4 and which is within the range of the function. So what we should do is we should take n equal to minus 1. N equal to minus 1. So this is equal to tan of minus pi plus 3 pi by 4 because now this is within the range. This is on simplification gives tangent of minus pi by 4. This is tangent of minus pi by 4. Now this is within the range. So we can write this as, say, this as 1, this as 2. So from 2 what we get is 2 implies tan inverse of tan 3 pi by 4 is equal to tan inverse of tan 3 pi by 4 is tan of minus pi by 4. So I can write this as tan of minus pi by 4. And tan inverse and tan change into identity. I minus pi by 4. And I minus pi by 4 is minus pi by 4. And this belongs to the range of the function. Therefore, this is the correct value. Tan inverse tan 3 pi by 4 is not 3 pi by 4. It is the wrong answer. It is minus pi by 4 because this does not belong to the range and this belongs to the range and a function can take values only within its range. No function can take values outside its range. One more example I am going to take up, that is sine inverse of sine, say, 7 pi by 4. 7 pi by 4. This is not equal to 7 pi by 4 because 7 pi by 4 does not belong to the range of the function. So what we do is we can write sine of 7 pi by 4 can be written as sine of n pi, sine of n pi plus minus 1 to the power of n into alpha. Alpha is 7 pi by 4. This can be written as sine alpha can be written as sine n pi plus minus 1 to the power of n into alpha. Alpha is 7 pi by 4. Now we have to choose n such that this is within the range of the function. That is minus pi by 2 to pi by 2. Now if I take, say, n equal to 1, if n is 1, this will be pi minus 7 pi by 4. Pi minus 7 pi by 4 is minus 3 pi by 4. But minus 3 pi by 4 is not within the range of the function. So n equal to 1 is not the correct value. Now take n equal to 2. N equal to 2, so this will be 2 pi plus 7 pi by 4. which is again not within the range. This is again not within the range. Now let n be equal to minus 2. Then this will be minus 2 and then equal to minus 2. This is plus 1. So this will be minus 2 pi plus 7 pi by 4. That is minus 8 pi plus 7 pi. That is minus pi by 4. So n equal to minus 2 is the correct value. Clear? N equal to minus 2 is the correct value. So what we do is we take sine n equal to minus 2 pi plus minus 1 to the power of minus 2 is plus 1 and 7 pi by 4. This is minus 8 pi plus 7 pi. This is minus pi by 4. So this is within the range. So we have to choose n such that this is within the range of the function. So n equal to 1 is not the correct value. I have explained it to you. N equal to 2 is not the correct value. But n equal to minus 2 is within the range. So this is the correct value. And this is equal to sine of minus pi by 4. This is, on solving, we get sine of minus pi by 4. Sine, so we can write sine inverse of sine 7 pi by 4 is equal to sine inverse of sine minus pi by 4, and therefore this is equal to minus pi by 4, and this belongs to the range of, so this is the correct value. Now I take up cos inverse of cos 7 pi by 4. This is again 7 pi by 4 does not belong to the range of the function. So what we do is we can write cos of 7 pi by 4 is equal to cos of, now cos alpha is cos of 2n pi plus minus alpha. So cos of 7 pi by 4 can be written as cos of 2n pi plus minus 7 pi by 4. Now what we have to do is we have to choose n such that this is within the range of the function. So what we do is say n is equal to 1. If n is 1, this will be 2 pi. So this will be 8 pi plus 7 pi by 4 is not within the range. But 8 pi minus 7 pi by 4 is within the range. So take n equal to 1. So n equal to 1, this is cos of 2 pi, and we will take a negative sign. We can take either plus or minus. Plus value does not lie in the range, but minus, this lies in the range of the function. So what we do is this is equal to cos of 8 pi minus 7 pi is pi by 4. This is within the range. So we can write cos inverse of cos 7 pi by 4. This is equal to cos inverse of cos 7 pi by 4 can be written as cos of pi by 4. And this is equal to pi by 4. And this belongs to the range of the function. So this is the correct value. Now for tan inverse. Tan inverse of tan 7 pi by 4. Tan inverse of tan 7 pi by 4. Now 7 pi by 4 does not belong to the range of. So what we have to do is tan of 7 pi by 4 can be written as 7, alpha is 7 pi by 4. So we can write tangent of 7 pi by 4 is equal to tangent of n pi plus 7 pi by 4. So this can be written as tan of n pi plus 7 pi by 4. Now we have to choose n such that this is within the range. This is within the range. Now, if I choose n equal to 1, n is equal to 1, then this will be 15 pi by 4, which is not inside the range. But if I take n equal to say minus 1, then this will be minus 4 pi plus this will be 3 pi by 4. 3 pi by 4 is again not within the range. So this is not the correct value. But if I take n equal to minus 2, n equal to minus 2, n is an integer. We can take values plus minus 1, plus minus 2, plus minus 3. So if I take n equal to minus 2, then this will be minus 8 plus 7. This will be minus pi by 4, which is within the range. So n equal to minus 2 is the correct value. So what we do is tan of minus 2 pi plus 7 pi by 4. N is equal to minus 2. And this is equal to tan of minus pi by 4. So we can write tan inverse of tan 7 pi by 4 is equal to tan inverse of tan minus pi by 4, which is equal to minus pi by 4, and this belongs to the range of the function, which is minus pi by 2 to pi by 2. So this is the correct value. And similarly, you can take more examples. Say sine inverse of sine 11 pi by 4, cos 11 pi by 4, and tangent 11 pi by 4. You can try this yourself. The solution will be within the range for n equal to 3. Here it will be within the range for n equal to minus 1, and on taking a positive side from here. Positive sign from here. And here it will be within the range for n equal to minus 3. You can try this yourself. I move on to the questions. Now here we are given y equal to cos inverse 2x square minus 1. Now to differentiate this, what we do is we put x equal to cos of theta, because pattern here is 2 cos square theta minus 1. 2 cos square theta minus 1 is cos of 2 theta. So we put x equal to cos theta. So what we get is y is equal to cos inverse of 2 cos square theta minus 1. 2 cos square theta minus 1. This is equal to cos inverse of cos 2 theta. And now there is a condition on x. X lies between 0 and 1. 0 is less than x is less than 1. This is say 1. This implies 0 is less than cos theta is less than 1. Now cos theta lies between 0 and 1. So within what range should theta lie? Now cos of 0 is 1 and cos of pi by 2 is 0. You can also keep the graph of cos theta in your mind. So it must be 0 is less than theta is less than pi by 2. Because we know cos of 0 is 1 and cos of pi by 2 is 0. And cos theta is a monotonically decreasing function. We will study this while doing the applications of derivatives. Here you can just keep this thing in mind. This is a decreasing function and therefore this must be 0 is less than theta is less than pi by 2. Cos of 0 is 1 and cos of pi by 2 is 0. So this must lie between 0 and pi by 2. You can also keep the graph of this function in mind. So this implies 0 is less than 2 theta is less than pi. And this belongs to the range of cos inverse theta is 0 to pi. So 2 theta lies in the range of cos inverse. So it can take values within its range. So we can say from 2y is equal to cos inverse cos of 2 theta is equal to 2 theta. It belongs to the range of the function. And this is equal to 2. Now x is cos theta, therefore theta must be equal to cos inverse x. So this is 2 cos inverse x, and therefore dy by dx is equal to 2 into differentiation of cos inverse x is minus 1 upon under root 1 minus x cube. That is minus 2 over under root 1 minus x square. Now I take up minus 1 is less than x is less than 0. Now in second case we are given minus 1 is less than x is less than 0. And therefore minus 1 is less than cos theta is less than 0. And therefore theta should lie between, now cos of pi is minus 1 and cos of pi by 2 is 0. This implies cos of pi is less than cos pi is minus 1. Cos pi is less than cos theta is less than cos of pi by 2. But this is a monotonically decreasing function. Therefore pi by 2 is less than theta is less than pi. Theta must lie between pi by 2 and pi. You can also keep the graph of this function in mind. So this can be written as multiply by 2. We have pi is less than 2 theta is less than 2 pi. Now this does not belong to the range of cos inverse x. Range of cos inverse x is 0 to pi. Range of cos inverse x is 0 to pi. Therefore, it can take values only in this interval. But this does not belong to this interval. Therefore, cos inverse of cos 2 theta cannot be equal to 2 theta. The values must be within the range. So now we know cos of 2 theta is equal to cos of 2n pi plus minus 2 theta. 2n pi plus minus 2 theta. Alpha is 2 theta. I have clarified all these things in discussion. This is equal to, you can also see the side sheet. Now we will choose n such that this is within the range of the function. So try n equal to say 1. N equal to 1. So this will be 2 pi plus 2 theta. 2 pi plus 2 theta will lie between 3 pi and 4 pi. 2 pi plus 2 theta. So add 2 pi. It will lie between 3 pi and 4 pi. So this does not belong to the range. M equal to 1, 2 pi minus 2 theta. 2 pi minus pi is pi. And 2 pi minus 2 pi is 0. So it will lie within the range. This implies for minus 2 theta. This will be minus 2 pi is less than minus 2 theta is less than minus pi. When we multiply this inequality by -1, the direction of the inequality must change. This is the main point you should keep in mind while dealing with the inequalities. Whenever you multiply an inequality with a negative number, the direction of the inequality must change. So this will come here. Minus 2 pi is less than minus 2 theta is less than minus pi. This will come to the extreme right and this to the extreme left. Direction of the inequality will change. So this will be minus 2 pi is less than minus 2 theta is less than minus pi. So always keep this in mind. When you multiply an inequality by a negative number, direction of the inequality must be changed. So this will now be 2 pi minus 2 theta, n equal to 1. If I take positive sign, it is not within the range. But if I take negative sign, this will be 2 pi minus 2 theta. Now 2 pi minus 2 theta, add 2 pi here. This will be 0 is less than 2 pi minus 2 theta is less than pi. So this will now lie within the range, that is 0 to pi. So what we write is, this will be cos of 2 pi minus 2 theta. Let n be equal to 1 and take minus sign. So this will be equal to 2 pi minus 2 theta. So we can write from 2 y is equal to cos inverse cos of 2 theta, and this is equal to cos inverse of cos 2 theta. 2 theta can be written as 2 pi minus 2 theta. And this is equal to 2 pi minus 2 theta. And this is equal to 2 pi minus theta is cos inverse x. So this is 2 cos inverse x. And therefore dy by dx is equal to, derivative of this is constant, therefore this is 0 minus 2 into differentiation of cos inverse x is minus 1 upon under root 1 minus x square. This is equal to 2 over under root 1 minus x square. So derivative is 2 over under root 1 minus x square. And if 0 is less than x is less than 1, derivative is minus 2 over under root 1 minus x square. In this interval, derivative is negative. In this interval, it is plus 2 under root 1 minus x square. I take up this question now. Now in part B, we are given y is equal to cos inverse 1 minus 2x square. You can see the statement on the side sheet. Now here the pattern resembles with 1 minus 2 sine square theta. 1 minus 2 sine square theta. 1 minus 2 sine square theta is cos of 2 theta. So what we do is we put x equal to sine of theta. So y must be equal to cos inverse 1 minus 2 sine square theta. And this must be equal to cos inverse. Now 1 minus 2 sine square theta is cos of 2 theta. Now we cannot write this directly as 2 theta because there are restrictions on x. First is 0 is less than x is less than 1. And in second case, we are given minus 1 is less than x is less than 0. Now 0 is less than x is less than 1. This implies 0 is less than x is sine theta. This is sine theta is less than 1. And this implies sine 0 is 0. This is less than sine theta is less than sine of pi by 2. And this implies 0 is less than theta is less than pi by 2, because in first quadrant sign is monotonically increasing, so direction of inequality is maintained, and this implies 0 is less than 2 theta is less than pi. A range of cos inverse is 0 to pi. Range of cos inverse is 0 to pi. And therefore this belongs to the range of cos inverse x. So we can write 1 as y is equal to cos inverse of cos 2 theta, and since 2 theta lies in the range of the function, therefore we can write this as 2 theta, and this is equal to 2 into, now x is sine theta, therefore theta must be equal to sine inverse x. So theta must be sine inverse x, and therefore dy by dx must be equal to 2 into, so differential of sine inverse x is under root 1 minus x square. 1 minus x square. So this is the answer. And in this case, minus 1 is less than sine theta is less than 0. And this implies sine of minus pi by 2. Sine of minus pi by 2 is minus 1. Is less than sine theta is less than sine of 0 is 0. And this implies minus pi by 2 is less than theta is less than 0. Multiply by 2. This implies minus pi is less than 2 theta is less than 0. Now this does not belong to the range of this function. This does not belong to the range of this function. So we need to do some simplification here. What we do is we know cos of 2 theta is equal to cos of 2n pi plus minus 2 theta. This is a standard result. We write this as this. Now we have to choose n such that this is within the range of the function. So what we do is let n be equal to, first is n is 0, then this will be plus minus 2 theta. So for minus 2 theta we will have pi multiply by minus 1. We will have 0, direction of inequality will change because we are multiplying by a negative number. So this will be 0 is less than minus 2 theta is less than pi. 0 will go to the extreme left and pi to the extreme right. Direction of inequality will change. So 0 is less than minus 2 theta is less than pi, and this belongs to the range of f. So what we write is, we write this as cos of minus 2 theta n equal to 0. Cos of 2 theta we know, cos of minus theta is cos theta. So cos of 2 theta is cos of minus 2 theta, and this is within the range. So we will have y is equal to, from 1 we will have y is equal to cos inverse cos 2 theta, and this is equal to cos inverse of cos 2 theta is, cos 2 theta can be written as cos of minus 2 theta. 2 theta is not within the range, but minus 2 theta is in the range of the function. So this is equal to minus 2 theta. This is equal to minus 2 into theta is sine inverse x. So this is sine inverse x. Therefore dy by dx must be equal to minus 2 into differential of sine inverse x is under root 1 minus x square. So what we notice in this interval, derivative is 2 over under root 1 minus x square. And in this interval, the derivative is not this, but minus 2 over under root 1 minus x square.